recapping ideas about energy transfer, whether overall a process is exothermic or endothermic in a given chemical reaction. So exothermic processes can be represented by a potential energy diagram. So I'm going to write PE. So on the y-axis, it represents the amount of potential energy. And in an exothermic process, the potential energy diagram would look something like this. Those potential energy diagrams, those are the ones in class that I described with the two platforms connected by a hill. In the endothermic, it'll look similar. Okay, so here are our two potential energy diagrams. The most left-hand platform always represents the reactants, the substances we start with. The pathway hill is the process of what's going on with energy to go from the reactants in order to form the product. So the more right-hand platform always represents the products. So and it doesn't matter which diagram that you are looking at, that when you are leaving the reactants and going up the hill, this is the place where energy is absorbed. And then, once when you reach the peak and you start the downward slide, okay, that always represents a place where energy is released. So in order to identify if a reaction is exothermic or endothermic, we compare the absorbed side of the hill to the released side. And whichever side is the longer side, we know that happened to a greater extent with the energy. So when we take a look at an exothermic process, reactants forming the products, the release side of the hill is much longer. So in this process, yes, some energy is absorbed, but more energy was overall released. So exothermic processes occur when the reactants release energy into the surroundings. And as a result, the surroundings warm up. And when you take a look at the platforms, and if there was scaling on here to represent the number of joules, well, we would see that the products would strike the y-axis at a lower number, so the products will always have less potential energy stored than the reactants. And overall, we can just say that energy left the original bond. So more energy left the original bonded structures. And because it left, it was part of the reactants and it left the reactants, we place it on the product side of the reaction. So if I was to do a little summary over here, I might write a general reaction like this. The reactants form the products and release energy. So I would see energy noted on the product side. Whereas in an endothermic process, when you take a look at those hills, the absorbed side of the hill is much longer than the released. So an endothermic process occurs when the reactants absorb energy from the surroundings. And as a result, energy is taken away from the surroundings, so the surroundings cool down. And once again, if we had scaling on the y-axis and we compared the amount of stored energy, or PE energy, that the reactants have compared to the products, we'll see that the products will hit the y-axis at a higher value. So the products have more stored energy or potential energy than the reactants. So in order for these reactants to form the products, energy had to enter the original bonded structures. So it's this reactant plus the energy in order to make those reactants. So this time we place the energy on the reactant side of the reaction. So if I was to do a summary reaction here, it would be the reactants plus energy in order to form those products. Now, you're going to have to be able to identify whether a given reaction is exothermic or endothermic, or identify the amount of energy absorbed or released. So your